Good morning, this is Mrs. Coleman, and today's lesson is about equilateral triangles. Today is day 19 of our stay-at-home school type situation, so I'll just go ahead and get started. Equilateral triangles are also called at times equiangular and at times called regular. We have a couple of corollaries, which are just rules that you don't have to prove. And it says a triangle is equilateral if and only if it is equiangular. So we know that it's equiangular when we see all the angles have the same marks. So you see those little marks there to indicate that. So if it's equilateral, that means all the sides are the same as well. Our second corollary says a triangle that is equilateral has angles that measure 60 degrees each. So, because all three sides of this triangle are the same, that means all three angles are the same as well. And each angle is going to be 60 degrees. So now I'm going to go over some examples, and this page is attached to today's lesson, and you can refer to it as much as you want to. So the two corollaries that I mentioned are up here at the top. And so we're going to take a look at these triangles. So number one, so for question number one, we see that all three sides are the same. So the corollary that I mentioned before shows us that all three angles have to measure 60 degrees. So if I'm trying to figure out what x is, angle F right here is showing a 6x in there, but we also know that it's equal to 60 degrees. So I'm going to write an equation that says 6x equals 60, and then I'm going to divide by 6 to show that x is equal to 10. For question number two, all three angles are the same, so therefore all three sides must be the same. Two of the sides have expressions, so I'm going to set those equal to each other and solve for x. So I think I shall subtract 6x from both sides, although there's different ways you can do this. So we have negative 5 equals negative x. Please note that x is not quite by itself yet. We still need to divide by negative 1 to get 5 equals x. All right. Some other questions on your assignment may ask you to take that a step further. So let's say that the question asks us, well, what's the length of GH? So once I figure out what x is, I can plug that in. So GH currently says 5x. Well, we know x is equal to 5, so I can take 5 times 5 to get GH equals 25. So not only does GH equal 25, but GJ would be 25 as well. You could plug 5 in. 30 minus 5 is 25. And even though this doesn't have anything marked on it as terms of an x, we know that because this is an equiangular triangle, all three sides must be 25. Question number 3. All three angles are marked the same to indicate that it's equiangular. And all three angles, each of them have to measure 60 degrees. So I'm going to take that 3x, set it equal to 60, divide by 3 to get x equals 20. Question number 4. We see that this angle is 60 degrees. Whoops, 60 degrees right there. Sorry about that. But all three angles are marked with those tick marks to indicate that they are the same. So even though it doesn't show it, AB would also have the same measure as AC and BC. So we're just simply trying to figure out what x is. So I'm going to set these equal to each other and solve. Okay, so x is equal to 10. Okay. Question number 5. Looking at this triangle, it kind of looks like it's just isosceles at this point because the two sides are marked. This is marked 60. So what I would really need to do to figure out these two angles is subtract the 60 from the 180, which is 120. But this angle, y, and this angle z have to equal each other because in an isosceles triangle, you see the two sides, these are called the opposite angles. So I take that 120 and I divide it by 2, and I get each angle measures 60. So now I've turned this into an equiangular triangle where all three angles are 60, all three sides are the same. So I'm going to write an equation where I'm going to have 3x plus 8 equals 4x minus 4, and then I need to solve for x. So I'll go ahead and subtract 3x from both sides, and then I will add 4 to both sides. Okay, so let's take this one a step further and find out what xz is going to measure. Currently, the expression for xz is 3x plus 8, but we already figured out what x is, so we're going to plug it in. So we need 3 times 12 plus 8. 3 times 12 is 36, plus 8 would make 44, so xz would equal 44. And the last example that we have all three sides are marked the same, all three angles are marked the same, so this is indeed an equilateral triangle and equiangular, if you want to call it that. So we're trying to solve for x, and we know angle T, even though it has a 4x in there, is also equal to 60. So I'm going to divide by 4, and I get x equals 15. Okay, so this example page will be attached to your today's lesson. Your assignment is over, I think it's on 3 separate pages, but there are a total of, let me get that number for you here. There's a total of 14 problems altogether. It's just a little bit spread out on the pages. So do your best with it, and if you have any questions whatsoever, please don't hesitate to send me an email, or we can do a chat or whatever you need to do. So have a great day.